Hello, everyone. I'm Christian Wade. We'll go ahead and get started. Thank you very much for joining me today. So we're going to talk about, as the title suggests, enterprise modeling in Azure AS and Power BI. We're going to talk about the roadmap, primarily around converging enterprise and self-service BI on a single all-inclusive platform, being Power BI. And we'll look at some of the new features that are mainly in public preview right now, but will soon hit general availability. And we can keep things pretty interactive. You can ask questions during the session. There are microphones here, or for a quick question, I'm happy to at least try and remember to repeat the question for the recording. All right? So just as an introduction, analysis services is 20 years old now. It was 20 years old in October of last year. We at Microsoft have a deep heritage in enterprise BI. We're the only vendor to be ranked in the Leaders Quadrant for Gartner's Magic Quadrant for BI and analytic platforms for the past 12 years. 12 years ago, self-service BI wasn't even recognized as a discipline, and none of these modern BI vendors were even, on the scene. So we have a deep heritage in enterprise BI in terms of the number of installations over the past decade or two as well. And we're the only one of the traditional BI vendors that really embraced self-service BI early on, right, with Power BI. So traditionally, Power BI is targeted at self-service BI users. So what we and the rest of the industry and the research agencies are realizing is that it's not as simple as just segregating self-service and enterprise BI. For consumers of BI artifacts, they generally don't even know where the data comes from, who created it. They just want to see the data for decision making. It's a more streamlined for them if they just access the data from one place. And also in terms of collaboration between the business and IT. If the business and IT share the same technology, it makes it easier to migrate BI artifacts across the two, and it's just a more streamlined process. There's a significant overlap in terms of data modeling in Power BI desktop for self-service users versus, say, SQL Server data tools for enterprise users. There are obviously some other features that are just for BI pros and for enterprise implementations that you may be aware of. So, by the way, let me just canvass the room. Like, who here has ever done BI modeling in analysis services? Don't want to put you on the spot. Okay, great. And presumably the number of people that have used Power BI is greater than that. I'm not even going to ask, but I'm assuming that's the case. All right, so what we announced basically at MBAS last year, Microsoft Business Application Summit last year, is that we're taking the analysis services functionality and we're putting it all into Power BI. So we are working actively on making Power BI a superset of analysis services. We've announced some big features in this space this year. For example, the XMLA Endpoints for open platform connectivity, which I'll talk about in a bit more detail. And so we want all of the analysis services functionality in terms of application lifecycle management and scalability, in terms of programmability and performance. We want all of that to be in Power BI Premium. So, for example, we announced XMLA Endpoints, which allows even non-Microsoft visualization tools to connect to Power BI datasets as though they were analysis services. All right? So any questions or comments or anything about that? No? OK. So who here has seen the aggregations demo in some shape or form? Wow. Who here has not seen it or alternative would, wow, I can, it shocks me how many people haven't seen it because it's gone viral. Every time I ask the audience, and I'm shocked at how many people have not seen it. So needless to say, I'll go ahead and show you it. So let's see. I have here a data set that is for a crowdsourced courier service where a smartphone app emits drivers' locations and generates a ton of data. All right, so each row in this driver activity table represents an individual location emitted by the app. And this location count measure, I can't zoom in because I'm on a VM, but as you can just about see, that's just the count rows of the driver activity table, right? It's just a straight count rows of the table. So I'm going to casually drag this onto the canvas to see how many rows we have in here. Now, who was here for Scott Guthrie's keynote, by the way? OK, so you may have seen some pretty large volumes. If they've already let the cat out of the bag and stolen my thunder, otherwise I would ask you, how many rows do you think are in here? Like 100 million rows or a billion rows. This is actually, in this case, Scott Guthrie's one was 6 trillion. This is actually a trillion, just over a trillion. If I go to this visualization, you can see the number of digits. So this is a massive amount of data. In this particular case, this is 1/4 of a petabyte of data from Azure Databricks, which, you know, up until pretty recently, I think in past the Professional Association of SQL Server keynote of the conference in 2017, I demoed 10 billion rows on Azure Analytic Services. That was a 400 gigabyte server that was like pushing the boundaries. I'm not going to name this competitor, but I watched the competitor do a 100 million row demo the other day. But anyway, the point being that we have just taken the cap off any scalability limit in terms of, for all intents and purposes, we've just completely blown any scalability limits out of the water. So this is 1/4 of a petabyte of data. It's highly interactive. I'm going to bring in distance traveled. I'm going to break it out by date. I'm going to make it a bar chart. I'm going to break it out by the miles per job. I'm going to make it nice and big. And I'm just getting instant response times over 1/4 of a petabyte of data. Just clicky, clicky, draggy, droppy data analysis over massive data sets. That's how we roll. All right, that's my catchphrase, by the way. You're free to use it, but that's fine. Anyway, so I'm going to go ahead and cross-filter using this feature in Power BI where we can just click on any random part of the report and it cross-filters other parts of it. So I've cross-filtered here by December 23rd, and I'm going to break out the location count. I'm going to actually make it a grid. I'm going to break it out by the drivers. So I've interactively, over 1/4 of a petabyte of data, created a list of drivers who worked on December 23rd, performed jobs of over 50 miles, subsequently left the company, right? And now I'm going to find Abigail Johnson, who I normally use. She's right here. And I'm going to drill through to see the actual movements for Abigail Johnson on this particular date, right? At this point, so the reason it was so fast was that it was hitting the in-memory cache in Power BI. So Power BI and Azure Analytic Services have an in-memory cache. They both use columnar storage. They compress data into memory, blazing fast performance. And we were hitting the cache at that aggregated level, right? But, you know, 1/4 of a petabyte is a lot of data to cache, even with our compression ratios. So the way that we make this possible is we cache the data at the aggregated level, right? Which is going to catch the vast majority of the queries, because most business intelligence queries are aggregated. And in the event that the user drills down to the detail level, as I did there, right, to see the actual locations for Abigail Johnson. Let me just see what's going on here. Then it's going to submit a direct query to the source. All right, so it's already finished that query. So this was the query that was submitted. So this query was submitted in real time. As I drilled down to the detail level, there was no cache. Right, that cache was about 15 gigabytes of data. Right, it's a trillion rows. Aggregated, it was about 1.68 billion rows, and that compressed to about 15 gigabytes. Right, so that's the kind of ratio that you can achieve. Right, so I've unlocked this massive data set in a way that would otherwise be physically impossible. Here we can see Abigail drove across Memphis just before the holidays. She then left the company. I like to think that she started her own company after that, and she did very well. The point being, we've unlocked this massive data set in a way that would otherwise be physically impossible using this aggregations feature, right? Okay? Any questions about that? I'm going to drill into how we actually set it up. Yes, go ahead.
Yeah, so that's my question. So is this do we have to have Azure service enabled for Power BI? If a user only have a pro license, can they do anything like this?
Okay, so the question was, if you only have a pro license, can you do anything like this? And then I think there was a secondary question about whether there is a dependency on an Azure service, right? So this does work in pro, right? So let me just answer that question off the bat, because I get asked that quite a lot, so I'll just clear it up now. We absolutely want to strive for a symmetric modeling surface between premium and pro. We want the differentiator to go to premium to be for the dedicated capacity for, dedicated for scalability and with larger SKUs and no noisy neighbors or anything like that. Now, in this case, this is enabled in Pro. In some other features like incremental refresh, which I'm going to show, currently is not enabled in Pro, but we want to enable it. It's just a question of doing the work. There is a cost associated. This is one of the reasons why incremental refresh is in public preview right now, because there's a cost associated with enabling it in both, and we wanted to get it out in premium. But yes, this particular feature is enabled in Pro. And to the other question about is it dependent on an Azure service, so in this particular case, this is dependent on Azure Databricks, but this works with pretty much any of our direct query sources. So it could run on a local SQL Server database if I want, right? It doesn't have to be on top of an Azure. It works on SQL Data Warehouse as well. Works pretty well on SQL Data Warehouse, but it's not dependent on an Azure database backend. Okay? All right. Any other questions? No? Okay. So I'm going to switch back to the slides and then to explain this conceptually. And then I'll show you how to actually set it up, right? So that was the kind of end user experience. I'm now going to explain the concept in a bit more detail and then how to actually set it up. So, with Azure Analysis Services, SQL Server Analysis Services, and Power BI was like this up until July of last year, was that you create the Power BI data set, right? The data, you create multiple reports on top of the data set, but you have to create this data set, and ultimately the Power BI data set is an analysis services instance, right? We have analysis services running in the background for Power BI, right? So you create the data set, and as I say, in Azure Analysis Services, SQL Server Analysis Services, the whole model has to be either direct query or import. And up until last summer, Power BI was like this as well. So if it's direct query, then as users interact with visuals on the report, it will submit direct queries on the fly to the source, right? So when I drill down to the detail level in the demo, it submitted a Spark SQL query to Spark, right? That's what we mean by direct queries, that pass-through layer that will generate SQL queries. And import, you refresh it on a scheduled basis. You refresh the data set, and then it retrieves that data, it compresses it, and it stores it in the in-memory column-oriented database for blazing fast performance, right? And I don't have any benchmark references, but let's just qualify it. In my opinion, we're the fastest BI engine on the planet. In terms of like-for-like query perf, the Vertipack in-memory storage engine, which is actually what is used as the basis for column store in SQL as well, is blazing fast, all right? But if you have complex calculations and stuff at runtime, that may change. But for straight, aggregated queries, I think it's fair to say we are blazing fast. So you either had direct query or import, but you couldn't mix and match, right? Where's my clicker? Since July of last year, we allowed you to pick and choose which tables you want to import, right? So you can get a much better bang for your buck. So in the case where I had 1/4 petabyte of data, even with our compression ratios, if I wanted to compress all of that data into memory, it would have been a challenge, right? So whereas now I can pick and choose which tables to cache, and I can balance, blazing fast query perf versus memory consumption, right? And I can cache the tables where it really counts. I can cache the tables for my executive dashboard or something like that. Now, so we call this feature composite models, right? Composite models is where it actually allows you to have multiple direct query sources, right? So you can actually get data from SQL versus Spark versus a ton of other places. And you can mix and match import and direct query in the same model. Now, then the thing that we built on top of this composite models feature is called the aggregations feature. So let's say that the sales table, which is currently direct query, so white means direct query, the dark green means import. So if the sales table is direct query and it's got 10 billion rows, you don't actually need a trillion rows to not everyone has a trillion rows. It's like, oh, I have a petabyte here or a petabyte there. You don't actually need that much data, right? You may just have like a billion rows or 10 billion rows or something where you could probably fit it on an Azure and Azure Services SKU which goes up to 400 gigabytes of memory, but that would cost quite a lot, and the management overhead of replicating all that data into memory could be quite expensive as well. So you have the option to say, you know what, I'm not going to cache that whole 10 billion rows in the sales table into memory. That would use up too much memory, and that would be a significant management overhead. What I'm going to do instead is I'm going to create an aggregated table on top of sales, right, which I'm going to call sales ag. In this particular case, it's just the sum of cells grouped by date ID, geography ID. This could be under 1 million rows. This will be tiny, right? This is like the non-empty cross-join of those two keys, which is tiny. Obviously, in the real world, you'd probably have a lower grain aggregation table with more rows than this. But in this case, this would be tiny. This would be super cheap to refresh into memory. This would refresh into memory probably in a few seconds, right, at a table of this size. And then what I can do is I can say, all right, so queries, so as the users interact with visuals on the report, Power BI generates DAX queries to the analysis services engine, right? The analysis services engine then will in turn submit SQL queries to the source, or it will just get the data from the in-memory cache. Make sense? Maybe I should include an architecture slide to explain that. But basically, users interact with visuals. Power BI submits these DAX queries. That is a DAX syntax right there to the analysis services database, which then in turn, depending on whether it's running in direct query mode or import, will translate that DAX query to the native SQL dialect, or it will just return the data from the cache. Make sense? Yep. OK. So in this case, we have this query that is just asking for, this is the DAX syntax to say, I want the sum of cells grouped by year and city, right? So in this case, it says that the query, the user, the report, they know nothing about this table called sales ag, right? No, you don't need to tell the user, oh, use this table and this measure if you want the aggregated data, and then if you want to go down to the detail level, use this different report or something like that, right? It's completely seamless to the user. Depending on what level they are in, what granularity they are, it will redirect the query. So here I'm asking for sum of cells grouped by year and city, and it says, oh, well, I can actually answer this from the cache because year and city are in the two dimension tables, geography and date, that are on the one side of one-to-many relationships to sales ag, and then it says, oh, I can just answer this from the cache, and I'll give you blazing fast performance. I'm not going to have to run a direct query on the 10 billion row table. Make sense? And then as soon as the user then drops in customer name instead, right, now it says, sorry, I can't get this from the cache. So internally, the engine will say, sorry, I can't get this from the cache. The user, there's no difference semantically from the user's perspective. But now it says, I can't get this from the cache because you're grouping by customer name. For one row in the sales ag table, there could be one row in the geography table. There could be multiple customers. I wouldn't know which customer to aggregate to. And it will, on the fly, revert to direct query, right? And it will submit a direct query to the source. Just like when I drilled through to the detail level in the demo, it suddenly submitted that Spark SQL query, right? So same concept. And you'll notice also that the date table is now white to represent that it's direct query, whereas when we were hitting the cache, it was dark green to show that it was in memory. So the reason for this is that if the date table can flip back and forth between import and direct query, it's going to be much more efficient because for the direct query, if you think about the SQL query that gets submitted, it's going to be sum of cells grouped by date ID, customer ID. If it can push that sum group by operation to the source, it's going to be much, much, much more efficient than trying to pull 10 billion rows and then do the join on the Power BI or Analytic Services Engine side. Does that make sense? So date has this actual special storage mode called dual, which means it can act as import or direct query depending on what is going to be more efficient. All right? So that's about that. And really, this is about as complex as it gets. If you've ever done aggregations in multidimensional, you had all these lattices, and figuring out whether you were getting ag hits was like a black art. If you've set up the model like this, you already know when you're which queries are going to hit the ag and which ones aren't. Right? It's a lot more straightforward. All right. So now I'm going to switch over and actually demo what I just showed. Any questions before I jump into the demo? Yes, go ahead. Okay.
So what we need is actually to consolidate them in the live query in our.
Okay. So yes. So if I understood the question, can you want to use Live Connect to an analysis services tabular model, and then you want to mash that up with other data on the fly from a different source? Yeah, in
Because we have tabular models that cover the whole enterprise.
yeah,
And in order to, we have more developers in Power BI than we have in tabular models.
yeah,
And we want to centralize the security,
yeah.
but let the users have the freedom in a way.
Okay, yeah. I think I understood. Yeah. So basically, you want to create a virtual model over multiple analysis services models in the back end, right? So we are actively working on that. Unfortunately, we don't have a time frame because the amount of work is significant enough that I would probably get in trouble if I made a commitment right now, because we probably wouldn't land it. So I don't think it's going to land in the next 5 or 6 months, but we are actively working on that. So that will be, we call the composite models kind of V1, where you have multiple direct query sources combining import and direct query. The composite models V2, maybe we should have named it slightly differently to more easily differentiate, will be that type of scenario where I have a kind of virtual tabular model, because ultimately a Power BI model is a tabular model. It's running an Azure Services tabular on the back end, right? So you'll have a virtual tabular model where you can pull data from different tabular sources. You can pull data from a local Excel file. You can combine those things into one model. So as I say, we don't have a time frame for that. But if you wanted to, yeah, I think that's as much as I'll say on that at the moment. Yeah, I think I'll cut it. Yeah. Yeah.
If the user has access to the tabular model, then yes, of course you can combine them, but you're not getting anything out if you're in the wrong group or user group.
Yeah. So, so the thing was that you want to centralize security, right? And just centralize the business logic for reusability, right? And so this is one of the traditional use cases for analysis services and kind of enterprise BI to reduce the number of models but maximize the reusability of the models. And so that's the approach that people normally take for analysis services. And so another thing to bear in mind is that we are making Power BI a superset of analysis services, so you would be able to have those large centralized BI models in Power BI in the not too distant future in terms of scalability and connectivity with XMLA endpoints, and so pretty soon Power BI will be a superset, so you will be able to create those large centralized models right there in Power BI. And as I say, we're also working on the composite models over Live Connect as well. Okay.
The problem is then that if we release the users and make it more freely to develop their own reports, then we need to move the security of the data they're actually seeing one level below. And the problem we're experiencing, at least, is that we can't do row-based filtering on the SQL server.
Yeah.
We don't know who's connecting.
Yeah.
So all the data across is
Yeah. So we can talk about it in more detail offline if you want, but yes, absolutely. We have good row-level security, and that's one of the types of business logic that we build into these enterprise BI models for maximum reusability. So you just define it once, and then you can get it reused. And as I say, Power BI already has row-level security. It already has the same semantic modeling capability. The tooling doesn't have some of the enterprise features yet, but with XMLA Endpoint, you will actually be able to deploy from SQL Server Data Tools straight to Power BI if you want. So you will get that kind of enterprise BI use case in Power BI in the not too distant future. Okay? All right. So let's come back to that later. And as I say, that is kind of aligned with the XMLA endpoint discussion that I'm going to get to if we get the time. I've always got more content than what I have time for, by the way, but that's fine. Okay, so here we have a data set, all right, in Power BI. To create these data sets, it is super straightforward. I created one at Amir's session yesterday. You just run a little wizard. You pick the tables you want from. This is from a SQL source. I just pick the tables, and it figures out which are the related tables. And it just generates the model for you. In this case, I haven't really done anything. You can add extra business logic in here, like row-level security, like KPIs and hierarchies and complex relationships and calculations, like BI calculations at the aggregated level, like year-to-date, month-to-date, 3-month moving average, and a bunch of other any kind of calculations that are more suited to the aggregated level are generally going to work better based on analysis services. If you can, for kind of relational level calculations, you can use Power Query, you can use data flows, or you can prepare it in your data warehouse using Azure Data Factory, etc. You can do the data preparation we normally refer to. That's more at the relational level. But then the calculations you build into the model are at the aggregated level, and that's where you're going to get really good performance. And this is where the calculation engine really shines in analysis services. All right? Okay. So I just ran the wizard. I brought in these tables. There is literally a table called Sales Ag. I may have renamed it to put a space in it, because this is where we define the user interface that the users will see. So we can put spaces in the columns and table names and stuff. But the SQL source wouldn't have that. But other than that, and I made it hidden, this is basically it, right? I didn't really do much to this model from SQL. And then, so this is my aggregation table, right? And it's just another table. There's nothing special about it. It's not like aggregations in multidimensional, right? It's just another table, and we're going to set up some mappings, just like we saw in the PowerPoint slides, right? It's just another table, and we're going to set up some mappings so that queries get redirected to hit the ag, right? In fact, right now, all of these tables are direct query, right? This whole model is direct query, and I haven't set up any aggregation mappings yet, right? As you can see, this storage mode here is direct query, and I'm going to go ahead and just query this model as is right now. So I'm going to ask for sum of sales by calendar year. And I just get back my numbers. And then here in DAX Studio, which is an open source community tool you may be aware of, it's showing, I just ran a direct query in SQL on the fly, and I aggregated data from the fact internet sales, which is what the name of the table is in SQL. Okay? Right? Now I'm going to come in and I'm going to set up an aggregate. I'm not even going to mess with the storage mode yet, right? So I'm going to leave everything direct query, and I'm going to come in and I'm going to say manage aggregations, and I'm going to set cells amount sum. So these are all the columns that you see in the ag table, right? So these are just the same columns that are in the ag table, and I've got the cells ag table selected. And so I'll say I want sum of the cells detail table, and the column is cells amount. There's some validation here, like I couldn't select that one because it's a different data type. There's a ton of validation that it does to make sure that you do it correctly, and it can, so I'm going to say I want the sum of cells amount, all right? So and then that's it, right? So I click apply all. So now I've got an aggregation set up so that queries that refer to the cells amount column from the cells table can actually be answered from the cells ag table, right? If they're at the right grain. What does the right grain mean? It means that you can group by any of the columns that are on the one side of one-to-many relationships to the ag table. So geography is fine. It will work for snowflakes, right? But for example, product is not fine because we can get from here to here, but then there could be multiple products for that particular row. It wouldn't know which product to aggregate to, right? So having done that, I now run this again. And in terms of the results, we'd get the same numbers back, right? We prepared that table in our ETL in this particular case, and so the data was already prepared in SQL. We'll come back to where the best place is to prepare it in a moment. And then here, you can see, oh, it's still submitted a direct query, because we haven't changed the storage mode or anything. But you can see that it actually got the data from the ag table instead. Right? Does that make sense? Okay. And also in DAX Studio, we have this nice little aggregate rewrite attempt. This is based off an event that is exposed in Profiler, is one of our events that would show up in Azure Diagnostic Logging for Azure Analytic Services if we had it hooked up to Power BI. But so the point being, we've got this nice little event that you can subscribe to, and you can easily see whether you get an ag hits or not, right? But so far, we're just in direct query. So this alone could be really useful, right, without even using imports, if you think about it. So you could use this for example, near real-time requirements. If you've got a scenario where you don't want to load the data into memory, you don't want to import it. So for example, a near real-time scenario where you're refreshing the model quite frequently during the day, that can be quite challenging to refresh the in-memory cache whilst users are querying the model at runtime. So you can avoid that and just aggregate the data in the source. You can use column store. You can use materialized views that will automatically reflect the changes that are in the fact table without you even having to do an import, right? This enables near real-time in a way that actually performs well, right? So just the direct query alone is going to give you, in some cases, a direct query model that will actually perform well and can work better for things like near real-time, okay? Any questions? No? Okay, so now I'm going to come back in here, and I'm going to actually change the storage mode of this table to import. Now, this is about as complex as it gets, right? Like I said in that slide, if you remember, the date table was flipping back and forth between import and direct query, right? So what it's asking me here is, if I'm going to set the cells ag table to import, it is recommending that I set the related tables on the one side of one-to-many relationships to be dual, right? So that they can flip back and forth between import and direct query. Right, what is it? So it's going to actually create an in-memory cache for each of the dimension tables. Dimension tables are generally a lot cheaper to cache into memory because there's a lot less rows and the cardinality is a lot lower. But this means that it will be able to, when I do a group by customer, for example, it will be able to get the customer name from the in-memory cache as well, and it's going to be a much better solution, right? So I'm going to go ahead and take it up on the offer and say I want to set cells ag to import, and I want to set the other ones to dual. So if you have like a large model with 100 tables, and you set it up as direct query, and you bring in all the tables as direct query, and then there's just a couple of tables you want to cache, you can let Power BI Desktop figure out what are the minimum dimension tables that you need to set to dual rather than trying to figure it out yourself. All right? So having done that, Obviously, this is a small model or small data set, so it refreshed quickly. And if I now run this, we would expect to get an ag hit again, but this time we should be hitting the in-memory cache, and we are. So we can see that we got a scan. So a scan instead of a SQL subclass means that it hit the in-memory cache. So I immediately know I hit the cache, right? And this here is not T-SQL. This is XMSQL, which is the SQL dialect that is used to query the in-memory storage engine, which we don't need to go there, but just so you know that this hit the in-memory storage engine, and the rewrite event says match found, right? So if that was a query that was initially taking a long time, now we'd be hitting the in-memory cache and it would be super fast, right? Make sense? All right. Now I'm going to run another query, which is again just asking for sum of cells amount, right? They're both asking for sum of cells amount, but in this case I'm asking for it to be grouped by product name, and product name is this table here that is not in dual mode and cannot hit the cache. The group by, as I said, you can get to product subcategory, you can get to product category, but you can't get to product because there could be multiple products and it wouldn't know which one to aggregate to, right? So if I run this one, it will on the fly switch to direct query, right? So the user doesn't know the difference, and here we said aggregate rewrite attempt failed, so it switched to direct query on the fly. Okay? So this is the equivalent of when I drilled down to the detail level on the Azure Databricks, and then it submitted the Spark SQL on the fly. The user doesn't know the difference, and it's completely abstracted. And so you catch the majority of your BI queries at the aggregated level using the in-memory aggregated cache. And then the ones that do get through to the source, they are more limited, right? So only if you had the whole thing as direct query, you have a bunch of queries going to SQLDB, you'd hit your concurrency limits, et cetera. So you get a more balanced architecture, okay? And moving on, so now I'm going to just quickly show you that we get good coverage in terms of a lot of the DAX functions. It's not just for, I set up the sum aggregation, right? So we want to, let's set up some other aggregations on here as well. So I'm going to go with, I've got a column in here in the aggregation table called fact internet cells count. So this is the count of the rows in the big detail table. So if I do a count rows, it should be able to redirect to this value, which is persisted in the table. So instead of count, I'm going to select count table rows, and then I select cells, and then now I don't specify a detail column because it's just the count of the rows, right? And if I apply this, and then I run this, and this should now hit the cache. So we've got a scan and a match found with the count rows DAX function, right? Now average, obviously this currently this isn't going to hit the cache, right? So attempt failed and it ran a SQL query. So how on earth could I even create an aggregate for average, right? I mean, for a start, I don't have an average column in the table. And even if I did, average is non-additive. It wouldn't be able to aggregate to any of the group bys on any of the dimension tables except for the exact slice of the exact keys, right? So, but we can actually make this hit the cache because this is an average of unit price. And if I come back here, and we'll go here. So what we can do is we have two aggregations of unit price. We have a count and a sum, right? So if we select count, cells, and unit price, and then sum of cells, unit price. So now I've got a count and a sum on the same column, on the unit price column. And so the average internally in the engine, it actually does a sum divided by a count. So it's aware enough that it will just automatically hit that cache. So this is actually one of the concepts that will help you to conceptualize. It's going to submit a separate subquery for each calculation, lots of different subqueries, and it's going to evaluate each subquery to see whether it can hit the cache, and if they can, then it does, right? So in this case, there's only one DAX aggregation function, average, but it generates two subqueries. In fact, if we look at the XMSQL for this, we've got, let's see, we've got a count and a sum, I don't know if you can see those, right? So the storage engine query submitted a sum and an account, and then the formula engine just divided one by the other, and we got an ag hit. Okay? Now, distinct count. Surely this isn't going to hit the cache. I mean, I must be on another planet, right? Distinct count is impossible. Well, actually, no, we can. So what we can do here, so if I run this, right? So if I run this now, it's going to run in DirectQuery. So I've got SQL. Attempt failed, so then it's running a distinct count on the source. If this was a 10 billion row table, it could take a while. So what we can do is, because we're doing a distinct count of the customer key, and the customer key is actually one of the group by columns. So we did sum of cells grouped by customer key, date key, and product subcategory key. So we've actually got all of the customer keys in the ag table, right? Because we group by the customer key. So by definition, we must have them all there. So we can actually just, all we have to do is call that out to the engine. Say, well, actually, customer key is actually a group by of sales customer key and now we get a scan and a match found. Okay, and then that saves us running a direct query against SQL against a 10 billion row table. All right? Okay, and lastly here, I'm just going to show that we've already seen sum and count rows hit the cache. We would expect this to work, but this is just illustrating that this works for complex measures. It's like the average generated 2 subqueries for one aggregation function in DAX. Here we've got 2 explicit aggregation functions in DAX, sum and count rows, which would again generate 2 subqueries. But you know, complex measures can take a sum divided by a count multiplied by the percent of parent or multiplied by the last non-blank value for inventory, you know, semi-additive measures. Ultimately, even that gets folded down to just a sum for the last date in context, right? So ultimately, everything basically gets folded down to a sum, min, max count or count of table rows. So even complex measures can hit the aggregation table, okay? Clear as mud? All right. Okay, any questions? No? Okay, you sure? All right, let's move on. What else have we got? I'm going to switch back to the slides. I haven't actually shown you. I could show you as well that, you know, there is the way we were modeling this was based on the relationships. There's another way to do it as well. You know, if you don't want to normalize your dimension tables, you can actually replicate the dimension attributes in the aggregation table as well. I'm going to probably skip over that in the interest of time. But for example, if you had a date table and you want to do an aggregation by month, and you don't want to have to normalize your date table into 2 separate tables, one at the month level, one at the day level, you can just replicate month, quarter, and year in the ag table, and then you set up those group by columns, and it allows you to not have to normalize. And for the big data scenario, quite often, you know, like on that trillion rows on the Databricks, those are completely denormalized, right? They're like file headers. You've got all of the dimension attributes right there in the fact table. There isn't a relationship in the whole model, right? So you could prepare another table in Spark and just set up all the group bys, and it would also hit the cache. Right? Does that make sense, or is anyone dying to see that? Otherwise, I'll skip over it. No? Okay, all right, great. So just to let you know, you don't have to rely on the relationships which would force you to normalize your model. Yes, go ahead. Yeah. Exactly. That's exactly right. Yeah, Power BI manages the tokens. Yeah. Yeah. Well, Power BI will manage the Azure AD tokens, so that when you refresh the cache or you're in direct query, it will use the right security context. Yes, yes. Okay, I see what you mean. So the question was around the token management on the Power BI side when it connects to the data source. So for scheduled refresh, as you described, Power BI stores the token in the data source, in the data source, the metadata that is in Power BI, right? And you as the dataset owner specify that, and it stores that in a secure, encrypted way, and then it uses those credentials to access the data in Databricks. By default, that's how DirectQuery, it will use those credentials for DirectQuery as well. It's not going to automatically do a pass-through of the current user's credentials. You can set that up as well, but that's not the default. By default, it will just pick up the credentials that you set up in the Power BI service. So you set them up once, and by default, that's what it will use for import and DirectQuery. Okay? All right. Any other questions? No? Sure? Yes, go ahead.
You just said you can do pass-through of the credentials, but is that only supported for Azure SQL?
Yes, I believe you're right. That's on the Power Query team. They are actively working on enabling that for other sources. Yes. Yes. I believe that's coming. Yeah. But like I say, by default, it will not do that anyway. You have to set that up extra. So row-level security, you can define row-level security in the source, in which case that's the only way it would work if it picked up the context of the current user, or you can specify row-level security in the Power BI model, right? And so whether it's doing pass-through or not, it will pick up the context of the current user, and it would apply row-level security based on the row-level security rules that you've specified in the Power BI model. That works fine. If you've got row-level security defined in Power BI, it can just pick up the context of the current user. You can set up the roles in Power BI, and that will work fine. And if it submits DirectQuery, it will be filtered for that particular user. Okay? Any other questions? No? Yes, go ahead. Okay, so the question was, when will Parquet files be supported? So they'll be supported in Power BI first, but the thing is that DirectQuery needs more than just storage. It needs a compute engine as well. So you will be able to just import from Parquet, but for DirectQuery to work, you need a Spark head on top of it, right? And you can obviously do that already today. You can already put a Spark head, and that's the only way that it will work with DirectQuery anyway. Okay? Any other questions? No? Okay. All right. Where are we? XMLA endpoints. Who's heard of XMLA endpoints? Just a handful of you. Okay. XMLA endpoints was first defined all the way back in 2002, and it's an industry standard protocol for client tools to communicate with business intelligence databases, and it's not just used by Microsoft. There are other vendors. There's a ton of other vendors that use it. So the first BI engine that supported XMLA endpoint connectivity was Analysis Services Multidimensional that got released in 2005, right? And so the way it works is that, you have an Analysis Services server, and you refer to it by server name, just like you would a SQL server or something, right? And then from there, we have a ton of client tools, whether it be Power BI, Excel, competitor products, or a custom app that generates its own DAX queries. All of these tools, normally, they will go through the client libraries that we ship for analysis services, right? Like Tableau Object Model and ADOMD and AMO, and we have and a few others. We have some client libraries. They all go through this XMLA endpoint. The XMLA endpoint is like a low-level thing that's abstracted from the consumers, but basically everyone that accesses analysis services goes through this XMLA endpoint protocol, which means that, that's why our competitor products create a BI engine, and then Excel can just connect to it and pivot tables just work because they're both going through, they'll open up an XMLA endpoint on their side, or their tools can connect to analysis services through the XMLA endpoint, right? Now, it's also used for management tools, debugging tools, profiler, and even SQL Server data tools in Visual Studio, and a ton of community tools like DAX Studio, which I showed earlier, and Tabular Editor, and BISM Normalizer, which is an ALM, like incremental deployment tool for analysis services. All of that goes through this XMLA endpoint. Now, the Power BI data sets run on analysis services in the back end, right? So it's not a huge stretch for us to just open up the XMLA endpoint for the analysis services instance in Power BI, and then instantly all of these tools automatically, all of these analysis services tools automatically migrate to Power BI. Does that make sense? Like when we launched Azure Analysis Services in, I think it public previewed around, I think it was part of 2016, it was a big deal that you could just take SQL Server Data Tools models for SQL Server Analysis Services, change the server name to be the Azure Analysis Services server name, and just deploy it, and it would just magically work. So it's going to be the same concept with Power BI. All of these, tools that, like SQL Server Data Tools integrates with source control and automated build and deployment, and all of these application lifecycle management processes and management and debugging, and all of these tools will just automatically work with Power BI, right? Power BI is going to inherit this world of capability from analysis services, right? So that's what the XMLA endpoint is. We've launched the read-only version of it. We have a private preview for read-write XMLA. If you want to participate in it, we can make that happen. So that's, and then you've got all of the programming models that you get with the client libraries. So this is the tabular object model. So for example, SQL Server Data Tools is a modeling tool for analysis services. It's just a tabular object model client. It just runs tabular object model code. You can create everything programmatically in terms of the data set through this. And then we have tabular model scripting language that you can run from SQL Server Management Studio, some PowerShell commandlets. All of this was working with SQL Server Analysis Services on-prem. Then it just magically worked with Azure Analysis Services, and now it will work with Power BI as well. Okay? And so let me see how we're doing for time. Oh, wow. I've only got 6 minutes. Wow. Time flies when you're having fun. All right. Incremental my quick demo. I've got just enough time to show you my demo of XMLA, but it's also based on incremental refresh. So the deal with incremental refresh is that Analysis Services has supported incremental refresh for 20 years. We celebrated the 20-year anniversary or 20-year birthday of Analysis Services and actually spun up an Analysis Services 2000 instance. And I'm not going to go into too much details, but suffice to say that you could generate partitions and do incremental refresh all the way back in, I think it was SQL Server 7 OLAP services, the first instance of analysis services, right? So incremental refresh, the deal is that you don't want to have to reload all the data. If you've got a big data set, it's just like a data warehouse. You run the ETL job at night, you don't reload all the data in the data warehouse. You'd need a week to do that, right? You're just going to do an incremental parallelized data load, and it's much more efficient, much quicker, much more reliable, doesn't depend on volatile connections to data sources and things like that. So it's the same concept with Analysis Services and Power BI. But the difference with Power BI is that we've abstracted all of the code that you may have required like 1,000 or 2,000 lines of code to manage all of those partitions. So we've abstracted all of that into this dialog where you specify this policy and say, I want to store a total of 10 years of data, but every time I refresh, just refresh the last 5 days because that's going to cover me for any data changes, for example, right? So the first time it refreshes, it will take a lot longer because it will load all 10 years, but subsequent refreshes will be noticeably faster. Make sense? All right. So I'm going to switch back to here. And so I have here I'm here in SQL Server Management Studio. And I've also got a Power BI workspace, CH-RAID incremental refresh, and I come into the properties for it, and then we have this workspace connection. This is the URL for the workspace that you can copy into the clipboard, and you can connect to it just like it was in an Analysis Services server, right? Very similar to Azure Analysis Services. So I've got that, and then here are the data sets in the workspace, right? And so if I put this to this side, I've already connected in Management Studio. Here you can see the same URL, right? And then here I've got the same data sets, and these are the same data sets that are in the Power BI workspace. So it looks like a duck, it quacks like a duck, actually is a duck. This actually is Analysis Services. We're just connecting to Analysis Services behind Power BI, all right? And so from here, you know, I can do scripting, I've got fine-grained partition refresh, et cetera. You know, like for example, here I've got this model that I uploaded from Power BI Desktop, right? I haven't got the time to show you it in Desktop, but I defined that partition policy in the dialog, and this is it. If I script it out from here, I say script, and then I'd get the script of the model. I didn't mean to do that. And well, there it is again. So it's got the policy right there in the create database statement. This is tabular model scripting language, right? And I've just lost my other one. Not to worry, I'm just running out of time. So what I'm going to do is I'm going to and actually let me quickly show you the partitions for this particular table. This trip table has just got one partition because I've just uploaded this from Power BI Desktop. The partitioning, the incremental refresh only kicks in when you publish it to the service, right? It's a service-side concept. You may not have the resources in your local machine to even deal with like a 100 gigabyte model once we open up the big models in Power BI. So there's one partition in here, and I'm now going to refresh it. So it should generate a ton of partitions for me. And in order to create this refresh script, I can come to the table, I can say process, and I'd say full, and then I'd click that script button, and it would generate something very similar to this, except I'm overriding the effective date here. And then now if I refresh this, we'll see that it generated a ton of partitions. And so here are the 5 historical partitions, and then it's got all the way up to the date that I specified here, August 13th. And the closer it gets to the current date, the lower the granularity of the partition is, so that it can maintain its contract to only refresh the last 10 days, right? And like I say, you used to have to write a ton of code to manage all of this yourself, whereas now it does it for you. And if I increment this by 1 day and run it again, we should see a new partition get generated, and it will opportunistically merge to get better compression, and it will drop old partitions that fall out of range. Right, so if we now refresh again, and so we got this new partition down here for the 14th, and you can see that there is a difference in the timestamp because the second refresh only refreshed the last 10 days, right, which on a massive data set would be much more efficient. Okay? So that's XMLA Endpoint, SSMS connectivity. As I say, a ton of other client tools will connect, and you'll get all of that Analysis Services functionality. The next big thing that we're working on is the big models in Power BI. So Azure Analysis Services can have up to 400 gigabytes of memory on the S9, and we're going to have comparative model sizes in Power BI. We've already let the cat out of the bag on that one, so it's not like an announcement or anything. But we're actively working on that, and then at that point, for all intents and purposes, Power BI will basically be a superset of Analysis Services, and it will, you know, and then you've got extra features in Power BI, obviously, that you don't get in Analysis Services, aside from things like data flows and paginated reports and the reporting. On the data set side, you get aggregations, you get composite models, you get policy-based incremental refresh, you get scheduled refresh, so you get a lot of extra functionality in Power BI as well. Okay? So I'm pretty much out of time, unless anyone, I'll take one question if anyone's got a question. No? Okay, well, thank you all very much. Go knock it out of the park, building enterprise BI models for your customers. Thank you very much.